Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 5 in the cross-site scripting module titled DOM XSS in jQuery Anchor href attribute sync using location.search source. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, select all labs, do a search on cross-site scripting labs, and then go to lab number 5. Titled DOM XSS in jQuery Anchor href attribute sync using location.search source. Alright, let's get started. This lab contains a DOM-based cross-site scripting vulnerability in the Submit Feedback page. It uses the jQuery library selector function to find an anchor element and changes its href attribute using data from location.search. To solve this lab, make the backlink alert document.cookie. Alright, so the target goal over here is to exploit the DOM-based XSS vulnerability in the feedback page and make the button that says back or the link that says back alert on document.cookie, which outputs the cookies that are currently in session for that application. Alright, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. When it comes to DOM-based XSS vulnerabilities, I don't really use the proxy. Instead, I use the developer tools in the browser itself to understand exactly where my input is going. And so for this lab, we won't be using the proxy, we'll just be using the browser. Now, as usual, the first thing to do is map the application and see if any of the parameters could potentially be vulnerable to cross-site scripting. The way to do that is by putting in a string in the parameter that you think might be vulnerable and see if it's reflected back to the user or potentially even interacting with the document object model. So the first thing we're going to do is click on Submit Feedback. You're presented with a feedback form. Let's put in our input, and as usual, we want it to be unique. So let's say test.test.ca, and then test1, and let's say test2 for the message, and click on Submit Feedback. And what we're looking for is any input that is reflected back to the user. Now you could see over here, this is a generic message saying thank you for submitting your feedback. It's not actually reflecting any of the input that I put over here. And if we right click and click on inspect just to confirm and do a control find and check for the string test, which is what we put in the name, email, subject, and message field, you could see that there's 0 matches. So it's unlikely that the vulnerability is in one of these fields. So what I'm going to do is right click and view page source to see if there's any JavaScript that is writing to the document object model. So if we go down over here right away, I could see there is some JavaScript over here, and it's specifically to the ID backlink. So if we look for this ID, you could see it's for the back button. So if we go back right over here, this is the back string. So this is what I call the back button or the back link. And the JavaScript is being applied on this link right over here. And if we look at the JavaScript itself, it's saying for the attribute href of the element ID backlink, it's getting that attribute from window.location.search from the return path. Now, where is this return path set? So let's find it and view it right over here. And interesting. So return path right over here is equal to whatever is set in the URL. So this is really bad because the URL input is user controllable, and so anything that I put after the equal sign right over here gets added as the link for the backlink over here. Now in a real world scenario, what you could do is enter a malicious payload over here that maybe redirects the user to a malicious website or executes JavaScript in the user's browser that steals the user's session cookies, which is exactly what we're going to do. So since we can control this value right over here, we'll just add malicious JavaScript over here that outputs the user's cookie. And then when this application runs, it'll enter the input over here, so our exploit, and save it in the href attribute of the back button. And so whenever the user clicks the back button, our malicious payload is going to execute. So for the malicious payload, all we have to do in order to complete the lab is get it to alert on document.cookie, which essentially just outputs the cookies for this domain right over here. So to do that, we'll say JavaScript alert document.cookie. And that's essentially it. All we have to do is now put it in this parameter right over here, so the return path. And I could see it didn't copy JavaScript, so let's put it in here. And now when I hit enter, the application will run. That script that we just analyzed will run, and we'll save this payload in the backlink. And now every time you click on the backlink, it should execute my payload, and it should alert on the cookies that are being used by this application. So let's hit enter. Right away, you see congratulations, you solved the lab message. But if we click on back over here, you could see this is the value that is stored in back. And so every time a user clicks on back, it'll output the content of the cookies for this application. Now we didn't log into the application, and the application is not using any cookies, and so it's empty. But in a real world scenario, the application will be using cookies, and so it would alert on the cookies that the user is using. Of course, in a real world scenario, you would actually have an attacker controlled server where the cookies get sent to your attacker controlled server, and this way you have the victim user's cookies and you could compromise the user's account. So let's click OK, and that is it. So we successfully completed the exercise by exploiting the DOM-based XSS vulnerability. In the next lab, we'll look at another case of a cross-site scripting vulnerability.